Hello, good morning everyone. I am Joy Bhattacharji from Technocrat Institute of Technology, Bhopal. Now, today I will discuss about concurrency control. So, what is concurrency control? Concurrency control when simultaneous transactions are accessing some database or shared database, it is called concurrency control. So concurrency control mechanism can be done with log-based protocol, multi-version technique, timestamp-based technique, etc., etc. Now today I will discuss log-based protocol. A log is a mechanism to control concurrent access to a data item. Data items can be logged into two modes: exclusive, that is represented by X mode. Data item can be both read as well as written. X lock is requested using lock X instruction. Shared is represented by S mode. Data item can only be read. S lock is requested using lock X instruction. Lock requests are made to concurrency control manager. Transaction can proceed only after the request is granted. So this is a table, log compatibility matrix. S is shared log, X is exclusive log. So shared log can be locked with shared only. When there is already a shared log, it cannot be locked in exclusive mode. Vice versa, when lock is in exclusive mode, it cannot be locked in shared mode, or it cannot be further locked in exclusive mode. A transaction may be granted a lock on an item if the request lock is compatible with locks already held on the item by other transaction. A number of transactions can hold shared lock on an item. But if any transaction holds an exclusive lock on that item, no other transaction may hold any lock on the item. That is being already said by me. If a lock cannot be granted, the requesting transaction is made to wait till all incompatible locks held by other transaction have been released. The lock is then granted. So this is an example where we are performing the log-based protocol. Example of transaction performing locking. There is a transaction T2, T2 lock S A. A is locked in a shared mode, then data item A is being read and the data item A is being unlocked. Then data item B is locked in shared mode, then it is being read and unlocked B. Display A plus B. Locking as above is not sufficient to guarantee serializability. If A and B get updated in between the read of A and B, the displayed sum would be wrong. A locking protocol is a set of rules followed by all transactions while requesting and releasing logs. Locking protocol restricts set of possible schedules. So what are the pitfalls of log-based protocol? Consider a partial schedule that there is a transaction T3 and T4. Lock is B data item is locked in exclusive mode, then B data item is read and data item is being subtracted by minus 50 and that data item is being written. T4 transaction, the data item is being locked in shared mode, then it is being read and then it is being data item B is being locked in shared mode. And T3 transaction A data item is locked in exclusive mode. Neither T3 nor T4 can make progress executing log XB because T4 to wait for T3 to release its lock while executing log X causes T3 to wait for T4 to release its locks on A. So every transaction is dependent on other transaction. T4 is dependent on T3 and T3 is dependent on T4. Such situation can lead to a deadlock. To handle a deadlock, one T3 or T4 must be rolled back. So T3 or T4 must be released. If one is released, then other can access that data item. Pitfalls of log-based protocol. The potential for deadlock exists in most locking protocols. Deadlocks are a necessary evil. Starvation is also possible if concurrency control manager is badly designed. For example, a transaction may be waiting for an X lock or an item while a sequence of other transaction requests and granted an S lock on the same item. The same transaction is repeatedly rolled back due to deadlocks. Concurrency control manager can be designed to prevent starvation. Now we move on to the next slide. What is two-phase locking? Two-phase locking has a growing phase and a shrinking phase. In growing phase, we obtain the locks and we do not release the locks. In syncing phase, we release the lock but we do not lock it. The protocol assures serializability. It can be proved that the transaction can be serialized in the order of their lock points, where the point where a transaction acquired its final lock. Now, two-phase locking. Two-phase locking does not ensure freedom from deadlocks. Cascading rollback is possible under two-phase locking. To avoid this, follow a modified protocol called strict two-phase locking. Here, a transaction must hold all its exclusive locks till its commits abort. Rigorous two-phase locking is even stricter. Here, all locks are held till commit abort. In this protocol, transaction can be serialized in the order in which they are committed. Two-phase locking protocol. There can be conflict serializable schedule that cannot be obtained if two-phase locking is used. However, in the absence of extra information, ordering of access to data, two-phase locking is needed for conflict serializability in the following sense. Given a transaction Ti that does not follow two-phase locking, we can find a transaction Tj that uses two-phase locking and a schedule Ti and Tj that is not conflict serializable. Lock conversion. What are lock conversion? Two-phase locking with lock conversion. First phase can acquire lock S on an item, can acquire lock exclusive on an item, can convert shared to exclusive lock. Second phase can release a lock shared, can release a lock exclusive, can convert a lock exclusive to the shared mode. So there can be upgrade or downgrade also. This protocol assures serializability but still relies on the programmer to insert the various locking instructions. Automatic acquisition of locks. A transaction Ti issues the standard read-write instruction without explicit locking. The operation read D is processed as if Ti has lock on D, then read B. Else begin if necessary, wait until no other transaction has a lock X. Write the automatic acquisition of lock. Where we are implementing the locking mechanism, a lock manager can be implemented as a separate process to which transactions send lock and unlock request. The lock manager replies to a lock request by sending a lock grant message. The requesting transaction waits until its request is answered. The lock manager maintains a data structure called a lock table to record granted locks and pending requests. The lock table is usually implemented as in-memory hash table index on the name of data item being locked. Now this is the lock table. Black rectangles indicate granted locks, while ones indicate waiting requests. Lock table also record the type of lock granted or request. New request is added to end of the queue of requests for the data item and granted if it is compatible with all earlier locks. Unlock request results in the request being deleted and later requested are checked to see if they now be granted. If transaction aborts, all waiting on granted requests of the transactions are deleted. Now, multiple granularity. Allow data items to be in various size and define the hierarchy of the data granularities, where the small granularities are nested within larger ones, can be represented graphically as a tree. When a transaction locks a node in tree explicitly, it implicitly locks all the node's descendants in the same mode. Granularity of locking. There is fine granularity and coarse granularity. So today I have discussed the concurrency control technique, and in that technique we have discussed only one technique, that is the locking mechanism. There are other techniques also, multi-version, timestamp based, precedence graph, etc. etc. So thank you.